Ready to start? Let me introduce myself. I am David Kelleher. I've been a PHP freelancer and developer for the last 15 years. I've also been a professor for 15 years. So I've taught and developed curriculum in Boston for several colleges over the years. I'd like to point out the link to the join in talk. Feedback would be really appreciated. And today's topic is web semantics. And here's my agenda. I'm going to talk mostly about HTML5 and JSON LD. At the end, I'll be a little bit of time to talk about more sophisticated, more advanced knowledge-based systems that are based on RDF. At a PHP conference, I know we all know HTML. I know we're all clear on the concept of separation of concerns so that we put all of our styles in style sheets. So what I'm going to discuss is a philosophy for the way that we should approach HTML5 coding to maximize the semantic value of the content that we have. Secondly, JSON-LT, which is a relatively new specification, became a recommendation in 2014, so a little bit over a year ago. And actually, last year, it was adopted by Google for their knowledge base. So JSON-LD has become really important to the semantic web. And finally, I'll give examples of more sophisticated knowledge systems based on a variety of RDF technologies. We can begin. Semantics is the study of meaning, and the field of web semantics is all about trying to take content and make it machine readable. So if computers can learn to interpret and analyze our content, we can create tools that do some really amazing things with them. And I'm going to give some examples of that at the end of the talk. So the challenge is to try and figure out how to create some formal systems where we can take our content and teach it to a computer what that means. So I'd like to approach this from the perspective of the computer. Imagine we have a string of text. For us, if you're going to tag an HTML document, it's very clear to you what all of that means. But remember, to a computer, it's just going to be a string of characters. And it's going to have no understanding of what's in your document. So, and you see what I have up here? Anybody read what this is? But we know what it is, right? 4176. Yes, 6F, 66. What language is this written in? If we were to consider this to be a language, what is the language? It's hexadecimal code, right? So I've taken some English and I've translated it to hexadecimal code. Just to now we're in the shoes of the computer. Okay? This is what the computer sees, and now we're kind of as dumb as the computer about what content I have here. So we're going to approach the beginning of this talk by figuring out how we use semantics to provide information about, first, the structure of this document, and then secondly, the meaning of the content that is inside the document. Okay. So right now, we have no understanding at all what this means. It would be very helpful if we did. So give myself a face palm right now, because we can't yet understand what that is. Begin to add some HTML code. Here are some divs and spans. Now, these are kind of the fallback default elements that don't really convey any semantic meaning. Divs are block level, and spans are for inline runs of documents. And we look at this, and we have no more information now about our content than what we did before. We can see how it's broken up. So we know what some of the specific sections are, but we have no idea what those sections are or what's inside of them. And there is a lot of code like this out in the wild, where you have divs and spans, where there's probably a more appropriate tag or element that actually conveys semantic meaning. And we also see a lot of examples of this out in the wild, where classes are just code like style1, or something else that doesn't really mean anything to anybody. So this is valid HTML. It's still following the separation of concerns because we're not putting any style information here. We have the style information separated on the spreadsheet, but we're not really accomplishing what we're supposed to be accomplishing with HTML. So we got two face palms for this. Now, we do know that HTML is a lot more than div and span. And all of the other tags do provide some semantic information about the structure and content of our documents. How would you typically see that first line marked up?
H1.
H1, pretty straightforward and obvious. How about this last section right here, what would you see? P for paragraph. What about that middle section? So here's the thing, right? Many people, right, would choose H2. And why do we choose H2?
Because it's bold.
It's big and it's bold. But remember, what is HTML supposed to be? HTML isn't supposed to convey any style information. And this is one of the traps that I think people fall into when they write their HTML code. If we read this, content that is marked up, blah, 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 there's 3 sentences here. What is semantically, what is that grouping?
It's just part of the content.
Yeah, it's part of the content. If I didn't make this bold and big, what tag would you choose for it? P for paragraph. This is actually a paragraph. Somebody chose to style this paragraph by making it big and bold. However, if you're writing the HTML, anybody who chooses H2 is actually doing it for a style reason because they just want to make it bold. When really the correct way to mark this up would be to call it P for paragraph because semantically it is a paragraph, and then do something in your style sheet that makes it big and bold. Does anybody know in publishing, what is the first paragraph of in a newspaper article or a magazine article where they make it big and bold? There's actually a name for that.
The lead.
The lead, right? So I would maybe, in the old days, call this a paragraph and give it a class of lead. And then in my style sheet, I would make the lead a little bit larger and a little bit bolder. So, and it's really good to talk about this. Sometimes I think that HTML is being really simple and really easy. It's the first thing everyone learns how to do. But conceptually, it can be more complicated than what it seems like at first glance. And that's why I hope maybe one of the big points you get out of this talk is to think philosophically about how you write your HTML to make sure that you're doing it in a semantic way. Yeah, so that one gets 4 face palms. So let's do this better. Back in the older days, HTML4, you'd probably see something like this. There would still be a lot of divs in there because at this time we did not have the new HTML5 structural tags. So you would see a lot of these divs, and that was the best that we can do. People would add these classes, like the IDs and the classes, and you could put some descriptive names in there, like film review, header. Now I'm using H1 and P in semantically correct way. So I now can see information about the structure of my document, that there is a header and a paragraph. Now, unfortunately, these IDs and these classes aren't really machine readable. So it's good for somebody, a programmer who's reading the code or has to maintain it, because we immediately see what's there. That helps us really understand what our content is. But from the computer's perspective, honestly, it doesn't really know what those things are. And that's because I haven't defined what those words mean in a formal way. So we'll get back to this problem a little bit later with a more recent solution that helps us overcome this. But we're making progress, so no more face palms. I'd like to review, just for a few minutes here, the sectioning elements, the grouping elements, and the inline elements in HTML, and talk about them from a semantic perspective. So we have the new HTML5 sectioning elements, and the sectioning elements are really there to help create a document outline. You would think of an essay or report that has a table of contents or an outline, and you would have maybe your chapters would be the top level of your outline. And then nested, you might have subheadings, which would appear indented in your outline or your table of contents. So these sectioning elements are meant to mark up the structure of that document in that way. So anything that would get a new listing or new line in a table of contents or document outline, you should use one of the sectioning elements for that. So we have headers. Nav was specifically designed for main navigation blocks, not for lists of links. Aside is tangentially related to the parent content. Address is not for a mailing address. Address was defined as the author of the document, so contact information for the author of the document. Footer and header, I think, are straightforward. The section is the fallback element that carries no semantic meaning. So my goal would always be to choose one of these more specific elements that did convey meaning. But if I had to create a grouping and none of the ones that exist were semantically appropriate, then I would fall back and use the section element. So that way it's like div and span. Span is your inline one, div is used for block level, and section is for sectioning. Yeah, so section is when you want to use it for the section element. And remember that in this case, the section should have an entry within the table of contents somewhere. So I don't know if there's really a whole lot of times or uses where it would be appropriate, but it might be. If you imagine and write out your document outline or table of contents first, and if you have an entry or a line in that outline and none of the other ones were appropriate, then yes, I would use the section element. The content grouping elements are typically your block level elements that are each displayed on their own lines when rendered out by a browser document. So these are your paragraphs, your lists, block quotes, and figures. And I think these are pretty straightforward. The text level elements are a little bit more confusing and a little bit more contentious. So we're probably familiar with the fact that the B element and the I element were deprecated or taken out of HTML4. Well, now they've come back in HTML5, and they were given specific semantic meanings. So it does confuse and complicate things a bit, but it also allows us to create some more tags or meta tags or semantic information about our documents using things that are concepts or tags that are familiar to us. So there are several ways in HTML5 to make something bold. So when you write your HTML, your job is to figure out, oh, if something should appear bold, you need to figure out which tag or which element you should choose. So if something is more important than the surrounding content or text in the document, then you would use the strong tag. If something is a warning, like danger, if you wanted the word danger to pop out in your text, you would use strong for that. For other reasons to make words bold, perhaps keywords in a textbook, or the article lead, which was the example we saw before, you would use the B tag for that. I think that some of these definitions can be a little bit vague and is open for interpretation. I could say that the article lead is more important than the other paragraphs in the document. So what I try to do is I look for specific use cases and examples in the specification. So if the specification gives an example of a keyword in a document and an article lead, then I would definitely use the B element for that because that's what's in the specs. And if it's not clear in the specs, I make my best guess. My college students love it because they can tag their documents and a lot of the choices are open to interpretation. So there are many correct answers and often it's hard for them to be incorrect. You can make the case that they've chosen an appropriate or semantically correct element, then I will accept their choice. Italics, same issue. There are now multiple ways to represent content that normally is rendered with italics in document. If it's emphasized, use the EM tag. The I element has come back. It's now used for alternate voices. One way you might see this if there's a foreign language phrase within English text. So sometimes that's rendered out as italics. example, c'est la vie. I could wrap that with the I element, specify which language it is using that attribute, and it would render out as italics. Cite is one of those contentious ones. They changed the meaning to be the name of a title of media, like a book or a film. In the past, it was really used to tag the author of your citation or a book that you were referencing. And do we know that there's two different set, like kind of official HTML5 specs out of there in the real world? There's the official W3 spec. They released 5.0 last year, and they're working on 5.1. And they have very specific definitions for everything. Pretty early on in the process, there was a second working group that broke off and created something called the living spec for HTML5. And these two specs are similar, but they disagree about the semantic meaning of some of the elements. So when we're doing this, it can be a little bit difficult because the world has not yet fully agreed on the semantic meanings for all of these things. So we just do the best we can, make the best choices we can, and you'll see how this field evolves over time. So in this slide, I've added in the HTML5 elements to the previous document. So I see article is now in there along with a header. I've coded the date using the time element, so now it's machine readable. I've changed my first paragraph to a lead paragraph, so I've done that with the B element. I put cites around my film names. You're not required to do this, but in the cases where there's multiple uses for some of these elements, like we saw in the previous slide that B could actually represent different possible things. It could be a keyword, or it could be a lead paragraph. Sometimes I'll put in a class here to help me identify the specific use of that element, and that makes it a little bit easier when I write my style sheets. I'll have specific classes for my paragraph leads, and then another set of classes for my keywords. So in my mind, it just helps things stay organized. We still have some of these classes and IDs here, like filmmaker, author, review, and lead. And again, we're still at the point where we haven't really formally defined what those words mean. But we made a lot of progress over the previous document. Especially here, it's really powerful being able to represent your dates in a way that computers can understand exactly what date that you're referring to. Okay. Queries can be a lot more powerful when you can tag your content with machine-readable dates. So I've been talking about how our class names and our ID names use words, but there's really no worldwide or formal agreement on which words to use for specific pieces of content. That's where microdata has come in. Microdata, most or best known originally for creating rich snippets in Google search engine. So rather than just listing like a title and some sample content from the page in the search results, Google could look for microdata on the page, which was content tagged in a machine-readable way, where you used a specific vocabulary to identify what pieces of your content on the page actually meant. So using this formal vocabulary that had been described, you could put in the star rating, the name of the person who wrote the review, the date that the review was published. And Google could store that information in its knowledge base and create a nice, formatted, rich snippet that would enhance the results that come out of their search engine. And more recently, we see what they're doing with the knowledge graph panel, which is the big box on the right side of the Google search engine, which is just a much larger, more sophisticated version, containing a lot more information from the knowledge graph. So here's how microdata has been done. Schema.org, the awesome, brilliant solution for hosting a repository of vocabularies that everyone would agree on. So when we're writing our microdata, everyone would use the same words from those formally defined vocabularies, and then anybody writing tools to take advantage of the content would then know exactly what pieces of information in our website meant. Originally, people with Google supported microdata and RDFA, two specific syntaxes for adding microdata to your HTML code. And there's a whole other technology called microformats, which was both a vocabulary, like the one defined at schema.org, and a syntax, like microdata and RDFA. It was both the syntax and the vocabulary rolled up into one. And it still exists. It's still being used, although not nearly as popular as schema.org. Just as about 1 year ago, Google switched over from recommending microdata and RDFA to using the JSON LD syntax. And that's going to be the next section of my talk. This is the old way that microdata was tagged in a document. And the important thing here to see from this page is that microdata is tagged throughout the document. So wherever we have a piece of content, like the name Roger Ebert, we see that the microdata attributes and elements that have been added surround that data. And this approach has some disadvantages. It's complicated, it's hard to learn, it's difficult to write. I tried teaching this to my students about a couple years ago, teach them HTML first. Then I would try to teach them how to do this type of microdata, and they couldn't do it. So, and there are also some other challenges, because in HTML we know that our elements need to be nested. But occasionally there was some of these schema.org properties that overlapped some of my elements. And so it didn't really fit the structure of my document. So it was really kind of hard to add the microdata that way. I kind of stopped doing it as well. But we can see here we have item scope, which is just saying that the entire element where the item scope is put is going to be using one of these schema.org vocabulary definitions to identify the meaning of content inside of it. We have item types, which are objects, and more recently actions as well, like a movie, like a person. And then you have properties of those objects, which are identified with the item prop attributes. So for example, the name of the film would be the item reviewed property of the movie object in my schema definition. So I've left that in for historical purposes. The way you would do this now is by writing JSON LD. JSON is JavaScript object notation. So it's just a way of representing objects using JavaScript syntax. It's exploded in popularity, primarily for web applications and APIs and sharing data between web services. JSON's been a very useful for that. JSON-LD, the LD stands for linked data. So it's kind of an extension of JSON, which allows us to link pieces of data throughout the web. So the old model of the web were pages that were linked together. This kind of semantic model of the web is data that is linked together. So when you have JSON LD, and here's an example of what the movie review would look like. We use the script element, and that could go in the header, or could really go anywhere on your page. You have to define application LD plus JSON. You'll see the at context is where we define which vocabulary we are using. So Google, for their knowledge base, uses schema.org, and that's probably the most popular one out there, but there are certainly other vocabularies, and if you wanted to, you could create your own vocabulary as well. So we put the URL of the vocabulary that we're using in the context. And then we put the object, which is called the type, in the @type. And so here I have the examples are review, person, and date published. These can be nested. So within the review property, I've put in the item reviewed, and I've chosen the movie object to pull the name of the movie from a separate object within the schema.org vocabulary. So you can nest these so that the value of one property could actually be another object in the schema.org definition. So now we're making progress. No more face palms. In my description for today's talk, I said that I would show examples for blogs in e-commerce. So here's an example of a live blog using schema.org. There is a type called live blog posting. There is the link or the ID, which is the link to the blog. There is an about property, which is defined using the event object, the start date of the live blog, and also a title for the blog. And then you can have multiple entries down here, each with a coverage start time, end time, headline, and description. Here's an e-commerce example. There's an object in schema.org for products. We've got an image and a name. And there's actually many, many different properties that have now been defined for the project type. So there's a lot of great things you can do this if you are selling online. There's also an offer section. So you can have multiple offers. You can list all of the offers for the project. Let's say if it's on Amazon.com has offers from other sellers. You can aggregate those and list the high price, the low price, and the number of offers that are available. One more thing I forgot, I wanted to point this out. There is the same as property. And this is what's used to link our data together. So for example, I've specified that the movie, let's see, I'll write down here, the person, the name is Roger Ebert. Here I'm using the same as property to link to DBpedia or a public database. And I'm linking to Roger Ebert's page here. So in this content, I'm specifying that it was written by Roger Ebert. I'm now connecting this piece of data to biographical database about Roger Ebert that has a lot more information about Roger Ebert. Maybe when he was born, when he was died, who he worked for, where he lived, nationality. So a web application that finds this data can link all of those pieces of information together and now start doing some really sophisticated queries on the web. Same thing up here, movie avatar. I meant to link that to the IMDb page for Avatar. I should go change that in my notes. So yeah, IMDb has, and some of these databases of movies and films have tons and tons of information. So I wouldn't have to specify all of that information myself. All I could say is, hey, I'm writing about the movie Avatar. If you want more data about that movie, for whatever query you happen to be writing, you can just follow my link to this other database. Okay. So we now have a web or a network of data.
Question.
Yeah.
So this would be on like the individual review, so that's all that's on that page, right? Is this review. If you had multiple reviews or multiple items, is there any semantic for that, or would you typically
So, with JSON, you can have as many objects as you want here. So let's say the page had 3 reviews. I could code all 3 of those reviews here on the page.
Okay. And the goal is to allow Google or whatever search engine to kind of be able to use this and present it.
The immediate goal for people who develop web pages is, there's value to doing this, because when Google indexes your page, they are going to pull whatever data you put in here and perhaps use that in their panel on the side or their rich snippets. So immediately there is that benefit. If you've got a business, it would be great if your business popped in the search engine by having one of those panels or rich snippets. And the only way you would get that, if it's your business, it would be up to you to do this coding. The only way you get that is by putting in this JSON LD into your document. That's an immediate benefit and it's really important. So we should be saying, everybody should now be doing this for your site. There's a secondary benefit, and that's part of the overall goal of web semantics as it was imagined way back in the late 90s, was to somehow create a worldwide collection of knowledge in a way that not only people could understand it, but computers could understand it as well. I think the way that human knowledge works is we have facts, and the facts that we know in our head, we know how they're related to each other. So our knowledge of the world is really just a collection of facts and relationships between facts that we know and understand. And so eventually, someday, we can model human intelligence and start having computers make intelligent decisions if it has access to kind of a system of all the world's knowledge that are organized in the way that our brains actually organize information. Kind of one of the holy grails of technology, kind of like artificial intelligence and natural language processing. These are great things, but they're also really, really difficult and are not going to happen overnight. People work on the problems year after year, and then all of a sudden we have computers that can beat chess masters. Yeah. We now have Siri on our phones that do natural language processing and can understand what we're saying and give useful responses a lot of times. So incrementally, decade by decade, there is progress being made to solving these problems. So hopefully, Google's come up with rich snippets and these knowledge-based panels. One of the reasons why they're doing it, they did that to give companies an immediate benefit so that they would start doing this sort of thing. But their larger goal is to kind of build this massive collection of data so they can make more progress to the larger goal of organizing the world's information in a way where we can do some really sophisticated, intelligent decision making. So two goals here in this process. A lot of the critics of the semantic web note how difficult that ultimate goal is and say, it sounds great, but it's not really going to happen anytime soon. So, but now that we have what Google is doing, we actually have reasons for starting to do linked data and to start kind of building up this worldwide knowledge of data. Yep.
I was going to ask, Facebook has its own way of doing this structure. So what is going to merge as the one that is used more globally?
Yeah, so Facebook is doing the same thing. Facebook wants to have a knowledge graph. And Facebook is really about people and the connections within people. And it's hard to say what's going to emerge. Like any standards, there are multiple options appear, and it just takes time to see what's adopted. Right now,
so who uses this one right now? Is it Google?
Google uses it, Bing uses it. Specifically, there are lots of people doing a lot of experiments with JSON LD. The biggest, best, most obvious use case right now is the main search engines, Google and Bing. I have some more examples coming up, so we can talk about that a little bit more at the end if you like. Actually, my next slide is about some of these use cases. And I'd like to think about how you would do this with search engines as they currently exist. So let's say I have a question for you. I want to find a list of Roger Ebert's favorite movies where there was an Asian director of photography. How would you get an answer to that question right now? Google. What might you type into Google?
Roger Ebert's.
All right, so you could type in these keywords, right? Roger Ebert's favorite films or 4-star films, Asian directors of photography. You might have to put that in quotes because otherwise you might get an Asian film or maybe it was an Asian actor. This would be really difficult to do, right? You could do the search. Hopefully the most helpful pages would be at the top, and then you could start doing your research on your own. All of, Roger Ebert has a site. Maybe you could go to Roger Ebert's site and do a search or filter for all the 4-star films. He did a lot of reviews though. This is going to take you a long time because for each film you would then have to go into the Internet Movie Database, look up the cinematographer, and then once you know the cinematographer, try and find out that cinematographer's nationality. Now imagine if everybody who has coded all of their web pages also coded within the page the JSON-LD, the linked data version. So if Roger Ebert's site, if every review on Roger Ebert's site followed that example that we saw on the previous page, you could then have a search engine that puts all of that information into a knowledge base and run a query on that says where the review author is Roger Ebert and the rating is 4 stars. Get me a list of that. And that it should generate a list of films. We could then, because the data is linked, instead of trying to do the research ourselves, the computer can automatically follow the links from Roger Ebert's review pages to the linked data that's been posted on the Internet Movie Database. Find the cinematographer, then maybe the cinematographer will have links to maybe biography pages about cinematographers, which could be on a database site, or might link to biographies that people have written about the specific directors to find out their nationality. And then we could write a single query that does this, or maybe you can use natural language processing to turn that question into a query that the computer can execute on its own. So once this database of the worldwide database of linked data has kind of been built up to enough where there's enough information in it, and it has to be valid data as well. Right? There's some unanswered questions right now. Who's going to check the validity of the data that's been posted? This is a problem with web pages too. Like, how do you know how good a web page is? That's a problem that Google has been working on since day one. But imagine if we knew that we had this large, valid data, worldwide database of linked data, we could very easily answer questions like this. And you could do a lot more sophisticated analysis on the world's information that are not possible right now. And so this is the promise of the semantic web. That ultimate goal is a long way off, but many of us are hoping that now that JSON-LD is a standard and it's easy to use, and it has immediate benefits for everyone who puts them on the page, hopefully we're making a little bit more progress towards that ultimate goal.
Christian.
Yep.
You say it's easy to use, and I think it is for any of us here.
Yep.
But more and more I'm seeing content being written by people who are technical,
Yeah.
And so if I'm Facebook or I'm a big company, I can deal with that. But
Yep.
for all the WordPress sites, are you seeing tools kind of come around this? Or?
Yes. And there's more of them that exist for microdata. But what you do is you'll be able to go to a website and it'll say, okay, what thing are you writing about? And you choose movie. And it will give you a list of fields. And then you can just type all that information in, and it will generate the JSON.ld for you. Right. So that's an excellent point. It's good that you brought that up so that I could mention it. It really needs to be that easy to become popular. So all of my students who are not technical at all, they're filmmakers, can embed a YouTube video on their website just by copying and pasting the share code. They can add linked data to their web pages now by going to one of those sites that generate this and then paste it in. Those tools, I look to see what tools are out there right now. There's not much. So if you're looking for an opportunity to help the world out, creating these tools, and it's a fairly simple project, I would imagine, to take a form and output the form as JSON.ld. It's not anything super challenging. And if you don't do it, somebody else is definitely going to do it. Because there's really, really good reasons right now for doing that JSON.ld stuff. Schema.org is also defining actions. So not just vocabulary of things, but also vocabulary of things that you can do. And Google is using this within their Gmail application for a task that you can perform your email. This is going to lead for the potential for agents and automation down the road. Where, let's say, if you were going to ask on your phone, ask Siri or whoever you ask based on whatever phone you have. Let's imagine that you've gone to a city and it's raining, so you're just going to go catch a movie. You might say, hey, what movies are playing near me? Right now, they could give you a list of nearby theaters. They probably know what's playing at the theaters. But let's imagine we now have this world where enough content, enough businesses have done this sort of work. Someday in the future, I could ask my phone to, maybe based on my taste in film, whatever I've liked in Facebook, find the movie theaters near me, choose a movie that I would like, purchase the tickets for me, and then load the directions into my phone. So businesses, right now, instead of having to go to the business's website to purchase the tickets manually, they can use these schema.org actions to allow it to be done by like a web API, make it a web service. So that this query that I asked my phone could then use, could act like an agent and use that automated interface for doing the ticket purchase for me. So agents and automations is another one of these promises of the technology. That hopefully, someday, and who knows if it will be in our lifetime or not, we'll get to the point where this work is done. So I think there's benefits. When you do this JSON.ld stuff, eventually people are going to start creating these tools. And it would be great for your business if when those tools are created, they find your stuff. So that without having to do any extra work, there are some potential future benefits down the line. Briefly, so I have about 5 minutes left. Expected there wouldn't be a whole lot of time. But I want to mention a few more of the more advanced knowledge systems and describe how they work. I think accessibility is really important for screen readers, for people who are blind. It's really helpful for the screen readers to know the structure of the document in more detail than is possible with HTML to help assist their users. So they have these roles, and I think one of the most important one is the role of search. We know we can see a search box for a website just by scanning the page. But somebody who's blind and has to have it read for them, it would be great if the browser could figure out which form represents a search feature for the website. And everybody should be doing this, adding role equals search to their search forms. And this organization has created a list of roles And people have identified which roles are currently do not exist in HTML5. And I would go through, follow that list, and use those wherever I could. Wikidata, which is like Wikipedia, only a database version of that, is trying to create a public database. So there's another work that's being done in this field. They use name value pairs, like area, 1572 square kilometers for London. Really wouldn't trust this right now. None of this data is referenced. Companies are using this to kind of push their own version of what they think the world's data should be.
Are those EAV models?
What's that?
Entity attribute value database models?
Specifically, let's get the slide here. They're specifically doing like a name value pair model. So it's not really a true relational database. They are a collection of objects where you create name value pairs for the objects. And none of these more advanced semantic knowledge bases, they don't use traditional relational databases. They have slightly different models. My next slide. Yeah, generally, you'll find knowledge bases more often use things instead of the entity attribute model using RDF, which is subject, predicate, object model, or a triplet, which is just a list of statements with the subject like Star Wars, which is a predicate, and then the movie is the object. And so now we can also define the relationships between things. So, for example, say that person A is a parent of person B. And that kind of goes beyond the linked data vocabularies we talked about, which is not just defining vocabularies, but here we're also kind of defining the relationships between those terms that have been defined in our vocabulary. OWL is one of the languages that have, or one of the syntaxes for doing that. Sparkle is a query language for querying a group of statements that have been written with the RDF model. This was used by the BBC in 2010 for the World Cup. Here is a page about England. Notice there is a link to an article that says pressure got to Rooney. This knowledge base knew that Rooney plays for England because they have that statement. So therefore, when doing a query using Sparkle to get all of the information, it doesn't have to exactly match the word England to have that article turn up here. It can analyze all the relationship of the data in the database and find out articles that are related to England, even if the word England doesn't specifically appear. I could extract stats for specific players, but if I know the relationships of the players, for example, Frank Lampard is a midfielder, I could run a Sparkle query that maybe gets the stats for all of the midfielders. And you can write, it's a lot easier to write super, super complicated queries that are really, really long. It's a lot easier to do with Sparkle and OWL than it is to do with traditional queries in a database. More simpler versions, I know it's going to be about time to wrap up here, so SKOS, S-K-O-S, is one of those knowledge organization systems for things that are really simple, like thesaurus and databases, and somebody figured out a way to encode those with JSON LD, so a couple more projects that are out there. Again, I really appreciate if you could give some feedback on joined in. That would be great if you could log in. That's very helpful for me as I kind of work on improving my talks from year to year. Any last questions before we go? I tried to answer the questions along the way. Any other questions before we wrap up? Okay. So it is 3:50 exactly. So perfect timing. That's all I have. Thank you very much.